All right, constructing model C, number 1. A gardener buys 2 kinds of fertilizer. A is 60% filler, and B is 40% filler by weight. So I got those 2 down. Together, so when I add those 2 up, we end up with 240 pounds. All right, so that's kind of my basic structure. And I want to do an equation. So X is A, so this is the X, and Y is the B. Well, if I'm looking at weight, 60% I can write as 0.60. So 0.60 of X plus 0.40 of Y would come out to be 240. So for this one, looks like the correct answer here would be B. Now they probably want you to pick D, but that's just kind of ignoring the percentages. So just be careful that with the percentages you use the decimals there. All right, looking at number 2, we have a graph of a sunflower's height over time. If you notice, it kind of changes. So the graph kind of starts off, at a normal growth rate, and then it goes fast, pretty fast, and then even faster, and then kind of fast, and then slow, and then it pretty much slows down. So it's changing over time. So it says the growth rate from day 14 to day 35 is, so I kind of went from day to day. They're saying that is pretty much constant. And by that, they're kind of meaning that it's linear. Constant change means it'll form a line. And it says, on this interval, which of the following equations best models the height, so the height, in terms of time, where time is in days. So I need to write an equation. I think the easiest way to do this is going to be to find the slope of this line. So if I make a little table here, and I have my time, and I have my height, and I pick a time point. Well, the time point at 14 days is, and I got kind of a big dot on there, so let's go in. I'm guessing this thing, I don't know, exactly. Hopefully, when I look at these slopes, they're all pretty far apart. So I think I can ballpark this, but looking somewhere over there, maybe we'll call it like 38. I don't know. So we'll just do 38. Hopefully that's good enough. And then I'm going to kind of come over to this dot, get a little bit better idea of where he is. He's almost in the middle. So I'm going to call it 130. I think that's good enough. So at day 35, time 35, we are at 130 centimeters. These are centimeters, these are days. So to find the slope, remember slope is simply change in y over the change in x. So looking at that, 130 minus that 38, so it changed by 92. And then when I look at the x's, 35 minus 14, that means it went up by 21. So 92 divided by 21, I'm going to go to my calculator here. And 92 divided by 21, 4.38. So I think that this is my slope, or somewhere around there. The only one that's really close to that, I believe, is B, because this is the closest number to a slope of 4.38. All right, next problem, number 3. Which of our equations relates y to x for the values in the table above? First thing that I notice is 2 of these equations are not linear. This equation right here is exponential, okay, which this is not constant growth, all right? Exponential means you grow like slowly and then you start going really fast, something to that effect. And because I see a little power here, and I see a power here too, so these are both exponential. And then these guys don't have power, so these 2 are linear. So let me see what's happening on my table. Well, my y values in my table I got to figure out, are they going up by the same amount? And looking at this, it does look like they're going up by the same amount. And to find the amount, so if you kind of, I always like to put my tables this way, and I'm not going to copy down all of these, just because that'd be a lot of writing. We don't want to waste too much of your time. So I'm going to put in the first few, 1, 2, 3, that should be enough to tell me. I have 11 quarters, 25 quarters, and 39 quarters. And so to figure out the change in y, to figure out what it's going up by, I need to subtract. So I'm going to do 25 fourths minus 11 fourths, which when you subtract fractions and they have a common denominator, you can just subtract the top and keep the bottom the same. And that reduces, when I divide both those numbers by 2, I get 7 halves. All right, so my change in y over my change in x. My change in y is 7 halves. My change in x is just 1, so that makes it nice. Anything divided by 1 is just whatever it is. So there's my slope. So it looks like the correct answer is D. Now I probably should have checked this change of y just to make sure it was the same. And so if I did 39 quarters minus 25 quarters, that comes out to be 14 quarters, which you'll notice was the same. So I know that this change is constant, which means that these two couldn't even be possibilities. Now, if your table starts jumping by bigger and bigger amounts, then you'll know it's exponential. That's covered in a later topic chapter. All right, number 4, energy per gram of typical macros. So if you're into bodybuilding or fitness or anything like that, you've probably heard of different eating methods, and a lot of people use what's called if it fits your macros, meaning they don't really worry a ton about the quality of their food, but just are they getting the right amounts of protein, fat, and carbs. But this chart's about the relationship. So it says, table above shows typical energy per gram. If X is equal to K, so X is equal to K kilojoules. X is food calories. If X food calories, so this is my X column, this is my K column. So I can kind of see that if I want to do my slope, for this problem it'd be changing K over the change in X. It looks like it's going up, when I subtract those two numbers, it looks like it's going up 21 kilojoules for 5 calories, which gives me 4.2 would be my slope. And so when I come down here, I see a bunch of them with a 4.2 in it, not him. But this is not a linear equation. And now I just got to make sure that it's set up right. This K should be on one side and the X should be on the other. And then 4.2 is my slope. So the correct answer here is B. This one looks really good, but they just have the X and the K in the wrong parts. Now, you could always have just tried to plug numbers in. Just stick this in for X and see if you get that for K. So you could have just done that as well. And the only one it would work for is right here. So for instance, even if you were tempted by C, you would have put in 4 equals 4.2 times K, and that's just not true. That's a false statement. So you'd have saw that way as well. All right, checking out number 5. What do we have here? Graph above shows the distance traveled by a product on a conveyor belt m minutes after it was placed on the belt. So our big ideas here are we have distance and we have minutes. And I don't know, I like doing tables. They kind of come out nice for me. So it looks like we have a 0, 0. And when m is 1, we get d of 2. And m is 2, d is 4. And I'll do one more, probably be enough. If it's 3, we're up to 6. So if I'm trying to pick the right equation, again, I could plug numbers in, or I'm going to do the change in y, or in this problem, change in d over change in m. It's going up by 2 every time m goes up by 1. So my slope is 2. Slope of a half, slope of 1. So right now I have two possibilities. They both have a slope of 2. However, this 0 gives me my y-intercept. So my y-intercept should be 0. This has a y-intercept of positive 2. This one has a 0. You don't really see it, but it is. Correct answer is A. Number 6. 1 pound of grapes cost $2. So grapes are $2 per pound. So for instance, if let's just say I bought 5 pounds of grapes, that'd be a lot of grapes, I would do $2 times 5 pounds, and it would be $10. But this problem's kind of weird. It says how many dollars will C pounds, meaning we don't know. So how many dollars times C pounds? Well, 2 times C is just 2C. So the correct answer here is A.